Hi class, this is lesson 7.1, factors and greatest common factors. Okay, so our first thing we're going to talk about in this lesson is prime factorization. And prime factorization just means we are going to write a number as the product of primes, okay? So if you remember from probably pre-algebra or even before, a prime number is any number whose only factors are 1 and itself. So like for example, some numbers that are prime would be 2, 3, 5, 7, 11, 13, and so on. It could keep going. But the only numbers that could multiply to give those numbers would be 1 in itself. So like for example, with 7, the only number that could multiply to give 7 would be 1 times 7. Okay, on the example they give here with 12, all of these numbers are correct representations of 12. 1 times 12 does give us 12. 2 times 6 does give us 6, or does give us 12, excuse me. However, the only one that uses a prime factorization is this one circled here in red, because 2 and 3 are prime numbers. On these other ones, 12 is not prime, 6 is not prime, 4 is not prime in these two. Okay, so the correct prime factorization would be with 2 times 2 times 3. Okay, when we do these as an example, we are going to be using something called the factor tree, and that's just a way to organize our work when we're dealing with prime factorization. So for example, I'm going to break up 92 to do the prime factorization. I'm going to start with 2 times 49, which gives me 98. It's a even number, so I'm going to just automatically split it into 2. That's maybe the easiest. Okay, 2 is on my list of prime numbers, so that branch of my tree is done. However, 49 can be split into 7 times 7, and 7 is, both of those are prime numbers, so that one is done then. So my final answer would be 2 times 7 squared, since I have 2 7s at the ends of my branches there. So that would be the prime factorization of 98. Okay, if I were to do the prime factorization of 40, I could start in several different ways. I'm going to start with, I just like to start with 2. So we could start with 2 times 20. 2 I know is prime, so that part is done. 20, I could split that a couple of different ways. Maybe I want to go with 10 times 2. Again, I know 2 is prime. And then if I split my 10 into 2 times 5, each of those is prime, so then I would be done. So the final way I would write that then is I have 3 2's, so 2 to the power of 3, and then times my 5. Okay, 33, there's only one way I can split that. That would have to be 11 times 3, and both of those are prime numbers, so that is completely done then. And my final answer there would be 11 times 3 as my prime factorization. Okay, for 49, we kind of already did that one in our 98 factor tree. If we look right here, there's our prime factorization of 49, so you can just copy that down right there. And our final answer would be 7 times 7, or 7 squared. Okay, 19 is a little unique because it's already a prime number. So the way we just write that, we can't really do a tree for it. We just do 19, or you could do 19 times 1, since that's the only pair of factors that would work to give us 19. Okay, next skill is something called greatest common factor. Again, this should hopefully be a review from some previous math classes that you've taken. In our example here, we listed out the factors of 12. If you remember from in the past, you might have been taught something like the factor rainbow. So 1 goes with 12, 12 times 1, 12, 2 times 6 is 12, and 3 times 4 is 12. We did the same thing with 32. We listed out all the factors. And then in red here, we have the ones that they have in common. So those would be our common factors, and then the biggest one of those common factors is 4. So we would say our GCF, or greatest common factor, is 4. Okay, so finding the GCF of some numbers, we're going to do that exact same process. So I'm going to list out all of my factors of the two numbers they give me, and then I'm going to see what they have in common. So for 100, I know that 1 times 100 works. I know that 2 times 50 works. 3 doesn't work, but I know that 4 works with 25. 5 and 20 is my other factor that comes next. And then I can also do 10 times 10, and I just need to list 10 once. Okay, and I think I've got them all then, so I'm going to move on to 60. So 60, I know 1 times 60 works. I know 2 times 30 works. 3 works with 20. 5 works with 12. And 10 and 6 works, so I'm going to squeeze those in. So 6 and 10. Alright, so then to find my GCF, I'm going to look at the ones they have in common. I can see that they've got several in common. 1, 2, 5, 10, 20. Those are all the ones they have in common. But I want to, of course, go with my biggest one. So my final answer would be my GCF is 20 then. Okay, the other method you could choose to use to find the GCF, I don't recommend this one as much, but it is a way you can do that if that makes sense to you, is you could use prime factorization. So doing what we did before, I would find my prime factorization of 26. So I know 2 times 13 works. Both of those are prime numbers. And then I'm going to do the same thing for 52. So finding my prime factorization of 52. I know that 2 times 26 works. 2 is prime, so it's done. And then I can do what I did over here. 26 factors into 2 and 13. So then I need to kind of do a little observing and see what's the biggest factor they have in common. And in this case, it would be 26. So my GCF would be 26. Okay, go ahead and try these next 2 problems on your own. Remember that you can check your answers with my answer key on my website. Okay, and then the final skill we're going to go over today is finding the GCF of monomials. So remember from last chapter that monomials is just one set of terms, and it all has multiplication in between each of the different numbers and variables that have to do with it. So we're going to start by doing something similar to what we did. We're going to list out the prime factorization for each one. So let's start with 15x cubed. To find the prime factorization of 15, you're going to just make your factor tree and ask yourself, okay, what prime numbers multiply to give me 15? In this case, it would be 3 and 5. So I'm going to list those out, 3 times 5. And then I've got x cubed, so that's 3 x's times each other. Okay, and then I'm going to do the same thing with 9. I'm going to do my factor tree of 9. And I know that the prime numbers that multiply to give me 9 are 3 times 3. And then I've got x squared, so I've got 2 x's in common. Okay, and then my next step then is I'm going to circle what they have in common. So here I see that they've got a pair of 3's, and they've got 2 pairs of x's in common. So for my final answer then, the GCF, I write down what I circled. So I circled a 3, and I circled 2 pairs of x's, or x squared. Okay. Now I see lots of people sometimes get confused. They think, oh, well, I circled 4 x's. Well, that's not true. You circled 2 pairs, and so that's what you want to go with in your final answer. Okay, so 3 and then 2 x's in common, so 3x squared. Okay, the next one, I'm going to do the same process, 16a to the 6th and 9b. I'm going to do the prime factorization of the numbers first. So 16, I want to break that into prime factors. So maybe you want to start with, I don't know, 4 times 4. And then that 4 can be broken into 2 times 2. And I know that 2 is prime. So there is where my factor tree would end then. So I've got 2 times 2 times 2 times 2. Okay, and then I'm going to have to erase this so I don't run out of room. But then I've got 6 A's that are going to go on the back end of that. Okay, and then for 9b, I kind of already did 9 over on that previous problem. So we know the prime factorization of 9 is 3 times 3. And then, of course, I've got my b on the end. Okay, so then to find my GCF, I'm going to circle what they have in common. And if you try to do that, you'll notice that there's nothing you can circle. This one's only got 2's, and this one's only got 3's, this one's only got A's, this one's only got B's. So they have nothing in common, so then I'm going to say that my GCF is just 1. If you recall from our previous conversation, every number can have a factor of 1, and so that's just all we're going to be able to go with on ones like that. Okay, so I want you to go ahead and try these next 2. Actually, go ahead, try the next 4 on your own, and then make sure you check it with my answer key and see if you're on the right track. Okay, and then last but not least, we're going to do just one of these story problems together. So it says the cafeteria has 18 chocolate milk cartons and 24 regular cartons. So I'm going to label these chocolate and regular. And we are going to arrange these cartons into rows so that there's the same number of cartons in each row. So think of that as like an array that we're going to make. And we are not going to put chocolate and regular milk in the same row, so we're going to keep them separate. And we want to know the total number of rows that there'll be if the cook puts the greatest possible number of cartons in each row. So what we are going to do is we're going to find the GCF of 18 and 24. And then that will be how many are going to go in each row, because remember, we're keeping them separate. We're not going to add them together or anything. So for 18, I'm going to list out my factors. I've got 1 and 18, 2 and 9, and 3 and 6. And I believe that's all of them. So for 24, I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And I believe that's all of them. So my GCF of 18 and 24 then, look at the ones they have in common. The biggest one they have in common is 6. Now, that's not my final answer though. This tells me that I'm going to put 6 in each row. Okay, so if I put 6 in each row, let's start with the chocolate. If I put 6 in each row and I've got a total of 18, that means I'm going to have 3 rows of chocolate, because 6 times 3 gets me that 18 for my total. Okay, and if I do the same with my regular milk, I've got 24 total, and I'm going to put 6 in each row. So 24 divided by 6 gets me 4 rows of regular milk. Now the question asks us how many total rows will there be? Well, 3 rows of chocolate, 4 rows of regular gets me 7 total rows. Okay? Alright, I want you to go ahead and try this very last story problem for yourself, and then check your answer on my answer key on my website.